After differentiating arithmetic sequences from geometric sequences, let us now proceed to determining geometric means and the nth term of a geometric sequence. Needless to say, we are going to be introduced to a new formula. The formula is a sub n is equal to a sub 1 times r raised to the n minus 1, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n right here is the number of terms. Let us put this formula to use in our first example. Let us find the fifth term of the geometric sequence 2, 4, 8. So let us use our formula. The formula is a sub n equal to a sub 1 times r raised to the n minus 1. So since we are looking for the fifth term, then a sub n is a sub 5. So a sub 5 is equal to a sub 1 is the first term of the sequence, and that is 2 times the common ratio. Last time around, we were able to identify that to find the common ratio, we should divide any two consecutive terms. So we take one term, we divide it by the preceding term, and the answer is the common ratio. So in this case, the common ratio is 2. So let's say, for instance, we take 4, we divide it by the preceding term 2. 4 over 2 is 2. Therefore, the common ratio is 2. And then n is the number of terms. We are looking for a sub 5. Therefore, we assume that we have 5 terms. So that is 5 minus 1. Let us simplify. We will have 2 times 2 raised to the fourth power. So we basically have 2 times 2 raised to the fourth power is 2 times 2, 4 times 2, 8 times 2, 16. And then we multiply it by 2, and that is our final answer. A sub 5 is equal to 32. Let us go to our second example. Example number 1's way too easy because the terms are whole numbers. Let us try a mix of whole numbers and fractions for our second example. We have to find the seventh term of this particular geometric sequence, 2, 2/3, 2 over 9. Let us have our formula. A sub n, no, actually since these are fractional terms, we write our the terms in our formula first. So a sub n, we list down the given data. A sub 7, a sub 1, the first term is 2, and the number of terms is 7. And then we solve for the common ratio. R is equal to the quotient. We divide any two consecutive terms. So let's say, for instance, we have a sub 2 over a sub 1. But what is a sub 2? A sub 2 is 2/3. So we write here 2/3, and then we write a longer bar So as we will know that 2/3 is the whole of our numerator, and then whatever comes after the longer bar is the whole of our denominator, which is a sub 1, and that is just 2. In this particular case, we have options on how to find the common ratio. On a normal process, if we are dividing fractions, what we want to do is to get the reciprocal of the denominator and then proceed to multiplication of fractions. So if that is the case, let us have a denominator for 2, which is 1, so we won't be confused. So this will be now 2/3 times the reciprocal of the denominator, that is going to be 1/2. And then just proceed to multiplication of the numerators and the denominators. And that is our common ratio, 2/6, or in simplest form, 1/3. So our common ratio is 1/3. Another option that we can do is to simply just multiply the outer terms. So we will have 2, and then the inner terms will have 6, or 1/3. This method is also correct. It will still give us 1/3 as our common ratio. So now that we have our common ratio, we have our n, a sub 1, and a sub n. Let us proceed to solving for a sub 7. Using our formula, a sub n equals a sub 1 times r raised to the n minus 1. So this will be now a sub 7 equal to, a sub 1 is 2, r is 1/3. Sorry, I'll write it clearer. Raised to the n minus 1, 7 minus 1. Let's just put these terms here. That's better. Let us now proceed. So we will have here 2 times 1/3 raised to the 7 minus 1 is 6. Now what we want to do is to sort of distribute the exponent 6 to the terms, to the numbers inside the parenthesis, or the numerator and denominator of the fraction inside. So 1 to the 6th power is still 1, and then we just simply solve for 3 to the 6th. And 3 to the 6th is just 3 times 3, which is 9, times 3, 27, times 3, 81, times 3, 243, and times 3, 729. Or you can simply just use your calculators to find 3 to the 6th, and you will find out that that is really 729. Now, let us proceed to multiplying the numerators and the denominators. We all know that we have a denominator 1 for 2. So our final answer will be a sub 7 is equal to 2/729. And that is our final answer. Let us now go to our third example, where we have to insert 3 geometric means between 4 and 64. If you are going to remember our arithmetic means, there were different methods that we used to find arithmetic means. And one of those methods is to find the common difference, and then from the first term, we just add the common difference until we get a certain number of arithmetic means, the required number of arithmetic means. That's what we are going to do here. It's just this time around, we are going to solve for r. And then from the first term, we just multiply until we get the required number of geometric means. So let us do that. So we have here 4. Then we have to insert 3. So 1, 2, 3, and then 64. So how many terms do we have? 1, 2, 3, 4, 5. We have 5 terms. Let us now use our formula. Solve for r, and then from the first term, multiply until we get 3 geometric means. So let us use our formula. A sub n equals a sub 1 times r raised to the n minus 1. What is a sub n? This is the assumed last term. So we assume that 64 is the last term. So therefore, a sub n is 64 is equal to a sub 1, 4. We are solving for r, which is raised to the n minus 1. How many terms do we have? 5 minus 1. We have now 64 is equal to 4r to the fourth. Since we are solving for r here, and it has a numerical coefficient and an exponent, we want to eliminate both of those. But let us, perhaps it is easier for us to just eliminate the numerical coefficient first. If we divide both sides by 4, we cancel 4, we are left with r to the fourth. So therefore, 64 divided by 4 is 16, equal to r to the fourth. In this particular case, what we want to do now is to express this side of the equation to an exponent 4. So we will think of a base that if we raise to 4, we get 16. Why is that so? Because the exponent of the other side of the equation is 4. So if the bases are equal, then the exponents are equal because we have here an equal sign. So that's what we are after. We will think of a number that is 2. When raised to 4, why 4? Because 4 is the exponent of the other side of the equation. The answer is 16. So 2 times 2, 4 times 2, 8 times 2, 16, which is equal to r to the fourth. Therefore, r is equal to 2. We are not going to consider the exponents anymore. So r is 2. So from the first term, we just multiply by 2. So 4 times 2, 8 times 2 is 16 times 2, 32. To check if the answer is correct, 32 times 2, that is 64.